Hi. Uh, Now today we are going to discuss about the master slave D flip flop. Here are the contents that we are going to cover. First is definition of D flip flop. Second, construction and working of D flip flop. Third, timing diagram, and final applications. We'll go one by one. First of all, we'll go with the definition of the D flip flop. Actually, the D flip flop or the delay memory element. It is a circuit having a single input and an output is equal to the input of the bit earlier time. If its output, if this is an input and for example it is having one input and we are considering it is an output, input and output, the input and output is equals to the input of the a bit earlier. That means it is a bit earlier. The output is a bit earlier than the input. The truth table, this is the truth table of the D flip flop. For example, if you are taking, if you are giving an input as 0, you are coming, the output is 0. If you are taking input as 1 and the output will be also the 1. The corresponding characteristic equal for the flip flop is of q power n plus 1 is equal to d power n. Q power n plus 1 is equal to, this is the same. That means this is both will be equal. This is the definition of the D flip flop. Next, construction, or we can say for the construction we are taking the logic circuit. The circuit, we are having the uh, both the you can say both the latches. These both are the latches, D type latches, and one is considered as the master and another is considered as the slave. Wait, I'm going to draw. Wait, if you're taking, this is the, this is a master and this is a slave. This is a master and this is a slave. Okay, again we will go with this uh, cursor. Okay, this is the input and this is the output. This is the input, this is the output, same like the input and the output. Okay, uh, it consists of the two latches. Actually we are having the two latches. This is the, this is the latch 1, this is the latch 2. Two D latches. These are two D latches we can consider. Uh, Clock input of the master, we connect clock input. Clock input to this for this master. We are connecting again with the by inverting. Again we are connecting to the clock by the master is connecting to the slave by the inverting of the this clock. This clock we are connecting, right? We are taking this clock signal to the inverting point and again just converting to the this point. That means this is a master and this is a slave. And the q output of the master, we connected to the d latch of the slave. This is a master and this is a slave. This q latch is we are connecting to the slave latch. Q latch of this master is connecting to the slave. For this output, it will become this input. Okay, got it. Next, we connect D input. For this D, this is the input. Okay, and the Q output for this slave, this this for this slave, Q output, this is the input and this is the output. Okay, and the same way Q bar, for this Q bar, this is the output. Right, this is the diagram. We'll go by taking this timing diagram. This is a timing diagram actually. uh, Assumption, we'll assume that initially this D is 0, this D is 0, this QM is 0, that means for this output, and this QS also 0, that means QS 0 means this is also 0. These four are the however these are the clocking. This it is connected to the clocking. Okay, right, we are assuming this as 0. Okay, this QM is equals to, which is the QM. Okay, for this input, this is the output. Okay, for the master of this latch, for this latch, this for this input, this is the output. Okay, QM. And when it comes to the QS, it is the Q output. This for this Q, it is output in the slave D latch. For this D latch, it is a QM as an output, and for this slave QS, Q is the input and this is an output, right? And we can say that Q is equals to QS. QS you can consider, right? That was an assumption we considered just now. And let us consider this time period. This is the actually the clock. This is a clock pulse. Okay, this is a clock pulse. We are assuming this is a time interval. This is T1, T2, T3, T4, and so on respectively. We can consider, and this is the like first of all, we are considering two types. That means let us consider time period where clock signal is high. At this point we should consider clock signal is high, the clock input of the master D latch is enabled. This will be in the condition of enabled, right? Okay, if this is enabled, however automatically this is disabled. This will be disabled, right? This will be disabled, right? This is enabled and this is disabled. Why this is enabled means because of we are taking the time period as high. Clocks in the clock signal we are taking signal as high, that's why it is enabled. Okay, master D latch is enabled. The input of the master D latch is high. We are taking this master D, the input will be high. Since since we are connected the inverted signal to the slave, this means this master inverted signal is connected to this slave. Okay, the input circuit, the slave D latch will be disabled. Just now I told that this will be disabled because of it is inverting and is connected to this slave. When clock is high at this condition, then this input will be low. When clock is high, then it should be slave D latch will be disabled, right? Okay, when D latch is enabled, that means this is in enable condition, its q output will follow the D input. it will follow the d for the q output. That means its output will follow the d input. It will follow like this. D input changes, its qm also changes according. D input will be changing, and it will the qm will be changing. Why it is changing? And it is changing because of it is in enable condition. As the master is enabled, its qm will change as per the value of d input. While we are while we are it is in the on condition, it is in enable condition. The master d latch, this d latch is the qm will change as per the input. That means changing means it will the changing will happen because of this condition. That means the clock pulse is high we are considering. Here d input changes from low to high. That means the same, from changes low to high followed by qm. The input of the changes from low to high. Here if we are considering this is happening. This is a d, the same. These both are same, like d and this qm, they are following same, like it is changing, and this is also changing a bit same. That means a bit same we are considering. This happens when the signal is high. Because the signal is high, that's why it is happening. It is followed by this, right? D followed by qm, right? This is the d and this is the q. It is followed by this. And the qm is d input of slave. This qm is input for this is input for this slave. So qm is changing, right? Qm is changing because qm is changing because this is the input for this. Because it is enabled, and it is as it is changing, this will also change. Because the slave is disabled. This is enabled and this is disabled, right? That's why the qs, it is taking that long time to take some, like the from zero, it is taking long time to jump. There is not that much sudden when compared to this. For example, like it is taking the clock pulse is this, right? The d, okay, we are it is changing when followed by this. The qm is changing followed by this because of this uh, like uh, it is like this latch is enabled, and this latch is master, and it is because of this high condition the pulse, it is following this enabled condition. And in the second scenario we are considering this is enabled, this is enabled, and this is disabled, right? This is second scenario. Why? Because we are taking this low signal, low pulse, low clock pulse we are taking. That's why this will be enabled, the slave will be enabled, and the master will be disabled in this condition. Same like the opposite scenario we are following. Now this slave will be enabled and the master will be disabled because we are considering the low clock pulse. The For any d input, for any d signal changes, for any d signal changes, its q output will not change. If it is changing, it will not change because it is disable condition. QM will not change because of this disable condition. That's why from the timing diagram, D signal is changing from high to low. That means from here it is like changing from high to low because it is in disabled mode, and QM does not change. Okay, because the master is disabled. This is a point. This is a disable. This is in disable condition. That is why it is not changing this value. And the clock input of the master is low, right? But slave is enabled. The slave part is enabled. The slave part is enabled. The QS output, for this QS, the output will change as per the value of QM. It will change as per the value of QM. The same scenario, like first, for the quite opposite of this first, the same second scenario will be happening. Okay, by this. Okay, this is the input, but this is out. That's why it is changing. QM was high. Okay, initially QM was high, and QS also becomes high. QM is equal to QS in this condition because of what? Because of the slave is disabled. See, because of the slave is enabled and the master is disabled. QM goes through this QM. It is goes through the D and it is goes through the Q, and it is uh, directly. I mean, whatever we are taking, it will follow. It will go through this, right? This QM will not change. Why? This QM will not change because of the master is disabled and it is enabled. It will not change. Okay. Even for the D input, okay, this D input, master D latch changes, QM won't change. This master D, this will change, but QM won't change. This condition, no, don't change. Don't change. QM does not change. Then QS value also depend on the does not change any further. QM does not change. This QM value does not change, right? Then the QS. This is a QS. It is also not change. It is not changing. It is not changing, right? Why? Because it is disabled and this is enabled condition. And the Q output. This is the output of the Q, and the QS output changes only, right? Q output and the QS output changes once. Only once it will happening, right? This is this once condition is this. The QS condition is only changing once. Here you can observe, right? For the first cycle, this is the complete one cycle, right? Q changes only once, right? Q changes only once. This is a Q only changes once, and that is the characteristics of the Q output. Q is changing only once, right? Here Q is equal to QS, only changing once. This we got this QM is equal to QS only once. And why it is happening? Because there is no stopping, there is nothing is stopping. Why? Because it is in enable condition. That way it is flowing directly through this. That's why it is uh, changing only once. Here it is not happening, this scenario. Okay, any changes in the master D flip flop happenings only at negative edge. This is a like positive. We can consider positive. That means at the negative edge only it is happening. Okay, this negative edge. In this negative edge, there is a change, and hence this is an in this negative edge there is a change, right? And hence this flip flop is called the negative edge triggered flip flop, right? That. and and we feel want to know about the applications. There are mainly, uh, not mainly, we are using this type of flip flop in frequency dividers. For the frequency dividing purpose, we are using this type of equipment. And the counters, storage registers, and the shift registers, which is related, mostly related to the, mainly only related to the electronics purpose only we are using. Thank you.